Hi, I am Andrew Castle. I am the Outreach and Process Coordinator for the Critical Zone Collaborative Network's Big Data Cluster. And today I am joined by, please introduce yourself.
Hi, Andrew. Sure. My name is Ijaz Ul Haq, and I'm currently a PhD candidate in computer science at the University of Vermont, specializing in AI and environmental data science. My journey into this field has been quite interesting one. I originally studied in computer science with a focus on machine learning and AI, but over time I became more and more intrigued by how these technologies could be applied to solve complex real world problems, especially in environmental science. So what really sparked my interest was like seeing how much data is being collected from natural systems, whether it's stream flow data, water chemistry, or soil moisture. So I realized that there is so much potential to use AI not just to crunch numbers, but to actually draw meaningful insight from this data, helping us understand environmental changes and disturbances in a way we couldn't do before. So my work has evolved into like blending advanced AI techniques with large-scale environmental data sets such as the camel scam to develop new tools for anomaly detection and time series analysis. So it's really a marriage of my two passions, technology and environment.
So I have a couple of questions. First, I want to ask, how is it being a PhD student?
Sorry again.
How is it to be being a PhD student? It's a lot of school to get up to there, a lot of different things, a lot of paths that you could follow, but you've decided academia is a place for you. Why do you feel like you can make a difference in the world on this path of
So
academics?
actually, I worked for industry for a couple of years before starting the PhD. I had done master's, so I then started working on the industrial side. But then I realized that I need some more knowledge, and I was interested in researching some new AI techniques. But in industry, we mostly try to apply something, and I had this passion to build my own new tools to solve some real world problems. So that actually gave me this motivation to, okay, let's start the PhD,
Is
and
this reason?
especially,
Oh,
yeah,
go
in
ahead.
the
Go ahead.
University of Vermont. Yeah, I mean, that's why I'm here. Yeah.
Talk more about what drew you to the University of Vermont.
So University of Vermont is unique in some aspects because of the environment around here. It's surrounded by all this nature like lakes, mountains, and there is a big potential so where scientists can apply their AI techniques to the environmental data. So actually, I was loving to work on environmental projects because that makes more sense. Environmental health is more important than anything. So University of Vermont was the location where I could do all these. And also, like we have a lot of support from this critical zone project, which I am funded because of I'm here, and they all are environmental scientists surrounding me. So I'm thinking that now I am doing some real work. Before I used to make games or some simple web apps, but I mean, those are good for some reasons too, but now I feel like I'm doing some real work which can be used by the scientists and around the world by anyone.
Is the research that you're doing, you just described it so amazing, bringing some of this AI and machine learning, data science and computer science together with environmental science. Are there scientists in the world walking the same line that you are, or is it kind of a rare thing to try to bring those two things together in the way you are?
I don't think it's a rare thing to bring these two together because nowadays there are people are mostly focused on interdisciplinary courses. Like back in time, people mostly used to be just in computer science, so they stay in that one area, try to build computational methods. And there, people are still doing that side of the work. But the point is that now there is a big need to apply these techniques, what they have already built, to different disciplines, just as environment, as we're talking about, or we can say medical health, or there are many things. So interdisciplinary. Work is I think nowadays it's universities are trying to build some department which try to merge courses together, like they will bring some computer science courses to the environmental science department as well. So this is the trend going on right now in the modern education.
This interdisciplinary work is exactly what you were talking about, this tool that you are working continually developing. I guess I'll ask this question first. Will it ever be done?
And the tool which I'm
Yeah,
building,
is it ever going to be complete, or is there always going to be something that you can add, a new way that you could have people work with the data? Like, when is it, like, is it a piece of art
so
that will continue to evolve?
So the point is, right now this tool is built on the top of a data set which we call Camel's Chem, and this tool is almost built. It's almost ready. It's there is just some work which I have to do. But the point is, this is just one of its kind of tool. There can be many such tools which can be built on many such data sets. One of the tool which is almost relevant to what we are doing is called MacroShed. They also build something on the top of water chemistry data sets from different sites, but ours is different because we are adding a lot of catchment attributes to it and more information. So I think it is going to be public soon. So we are working on that, and already I released the first draft of it to the group and or cluster in the critical zone. So getting some feedback to improve, and then it's going to be online, and people will be using it for different purposes, maybe teaching in classes and everything. What they
But it's not like a game where there's going to be downloadable content that will come, or a patch that you'll put out there. Like there'll be a time when like this is the final elegant product.
Yeah, it's gonna be online just as a website. Like we call it web application because it involves some, and it's not just a static website, but it's like dynamic in a way that it has functions involved. We play with elements on the website and try to extract data and then visualize in, yeah.
The thing that just maybe, so you're talking about the web application, and it's a way it's inviting people to use it and manipulate it and to try different things. And you also talked about you had worked in game development. Does some of that game theory and game development come over to make the web application fun to use?
So yeah, I mean, like as a developer in past of this uh, game developer, you can say, or some web developer, I have done work of similar in a similar way. But this, I mean, environmental science and gaming, I'm not sure if I can bring a gaming idea to let the people play with that. For example, something coming into my mind right now is that if I am to build this tool for like students from for elementary school, so it cannot be like such straightforward, like okay, select this, select that. It should be in a way which can make the learning fun. So in that way, we can bring some gaming techniques in that, so student can play and learn. So depends on the audience, what age your audiences are. If they are a young crowd, like kids, then you of course should have a web app which will be which can help them learn in a fun way rather than just scrolling here and there and do not learn anything. So it depends on the audience. But currently, this version is mainly for the scientists working in this environmental area, and they're like you could say at least bachelor's, master's students. That's the level of the web app audience that should be.
You mentioned that you're working with this Camel Chems data set, which is it's been around for decades. The Camel's Chem data set has been. How is it for you, personally, to find new ways to use this data that has been trusted by so many scientists to be able to look at it in a new way?
Mm, so this tool is actually a versatile one, and Camel's Chem data is actually it's like 39 years of data we are covering right now, which covers 1500 and no 516 headwater catchments. That includes a wealth of data like chemicals concentration, calcium nitrate, like dissolved organic carbon, and catchment attributes like stream flow, precipitation, soil information, or rock information. So the point is, it's gonna be a versatile tool, and that's one of the biggest strengths. So I see it being used by scientists in a variety of fields, like from hydrology and environmental chemistry to climate science and beyond. So a key feature is the way it allows the user to focus on what matters most of their research. For example, if someone is studying the effects of climate change on water system, so they can quickly filter the data by date ranges, chemical elements, or catchment attributes and see spatial variation mapped out clearly. So not only does this save time, but it also enables a much deeper exploration of this huge data set.
Is that part of your broader research goals?
So my research is heavily centered on blending the AI techniques with environmental science, particularly when it comes to time series analysis of environmental data. But these kinds of tools like fit perfectly into the narrative because they allow me to visualize and analyze vast amount of hydrological and chemical data across multiple sites and time periods. So a significant part of my research actually involves these days detecting anomalies in environmental time series data. So whether that's unusual peaks in water chemistry after a disturbance like a wildfire or patterns of recovery in soil moisture. So with such tools, if I keep building more and more, I can effectively map out like where these anomalies occur, for example, correlate them with other environmental factors and assess their impact. So they support my work in automated anomaly detection, like where I can leverage machine learning model on this web app in future, not currently. Currently, we are just exploring the data set with the web app, but these can be the future work, like when the 2.0 versions come out, 3.0 version of the web app comes out. So these gonna be there's gonna be new machine learning techniques involved in that. So where I can leverage this new models like transformers to flag um, deviations from normal pattern. So this helps not only in understanding short-term environmental disturbances, but uh, also in identifying long-term trends and maybe like I say overlooked in static analysis. So in short, these tools, yeah, enable like a much more dynamic interaction with the data, like aligning directly with my goal of advancing AI-driven environmental sites.
Has being a part of the Critical Zone Collaborative Network really inspired your imagination to develop tools like this, to ask these questions, to build these bridges between scientists and the data that they collect?
Of course, like as you know, critical zone cluster, it's a big team, right? So there are uh, guys who like working on educational side of this project. Some are working on collection of data. Some of us, like me, trying to apply some new technologies to work on these data. So in a way, can you repeat the question? I just forgot that
Oh,
last part.
no, there's working with the education team, the scientists that are out in the field, and then your work. How does it inspire your imagination
Oh
to
yeah.
to create
So
tools like this?
So the point is that's a good point. So I'm like thinking of at the end, like when I hear the team, the education team, what they are doing, they are going to schools and trying to educate kids with all this environmental science. So I want to help, like at least in a broader community, that specific team of educational area of this critical zone to help them. Okay, now we have this tool and they can just bring it to the students and directly let them interact with these tools. So these are all very good source of motivation for me because people are gonna learn from what I have built. So of course, the good feeling at the same time and also a feeling of achievement that, okay, I did something good.
Last question for you, and thank you for taking some time. We'll link the link to the preview tool that people can explore down here in the video so they can see it and sort of find out how it's working. But my last question for you is some of these people, these young people that you just talked about that are working with the education team or just in school, they might be thinking about a career in science or computer science or pursuing something that really interests them. How would you encourage them to pursue a scientific career?
So I think computer science is nowadays like it's very important. The time when I joined computer science, it wasn't that field which everyone would like to go to. People would go to different kind of engineering, electrical engineering, civil engineering. But as the time passed, computer science and its courses became the core courses of all of these other majors. And then if a student is all equipped with all these courses and the tools he learned in just purely in computer science field, for example, in the bachelor's degree, so that kind of student can just go into any area in any engineering side, like in STEM field, because the tools or these programming languages are the hardest to learn. So when they have all these skills, so for them it's very easy to jump from one field or to join an interdisciplinary area where they can be easily applying and maybe perform better than those students who have not learned like those courses as them. So I don't see any area in this time of the like 2024, this I don't see any field which does not need computer science. It's the core, and things are evolving very fast. Things are automating. So the more earlier the students catch with the time, they're gonna make something good out of it. Otherwise, there is also a harm that AI may take over all the jobs and can do all the programming and everything on itself. So they need to find out, like for example, the data entry jobs and these basic level jobs are already taken off, and I'm seeing companies are laying off big number of employees every time. So there should be some research while joining computer science. Students should keep in mind that, okay, what are the areas left for us, and till what time we could survive a degree in computer science to be in the market. So there are some areas, for example, I would say AI work and cybersecurity. And the thing I'm doing, for example, I'm doing anomaly detection. It's kind of cybersecurity kind of thing, but for environment. So I'm trying to detect the anomalous um, patterns which the environment or the nature creates. So I'm doing cybersecurity versus AI for the nature, but there can be for many things for banks and like, so those areas are still, they still need the research and the work which computer scientists have the knowledge for. So they should do some research. I mean, do not demotivate anyone, but things are changing very fast. So they need to learn what area will last till longer, then it becomes fully automated and they don't need a human anymore.
Cybersecurity for nature. I love that thought. What a great way to describe your work and research. Thank you so much. I'm going to stop recording and we'll say goodbye off of the recording. Thank you.
Thank you, Andrew.